Linux on open source hardware with open source chip design. Who here in the audience uses Linux? Please, a short sign of hands. Feels like almost 100%, I would say. Okay, 100% of people use Linux. So who of you uses it on open hardware? Please, another show of hands. Yeah, that's not too many. Who of you would like to use it on open hardware? And I guess that's why you're here. So I'm glad that we have Drew Fustini here, our new speaker. He's an open source hardware designer and embedded Linux developer, and also the vice president of the Open Source Hardware Association. And who better to tell you how to run your Linux on open source hardware? Please welcome Drew with a big warm round of applause and have fun with this talk. Thank you very much.
Thank you. Thank you. I'll skip past my introduction. It's Congress, so probably most people are familiar with open source. So before I jump into what open source hardware is, just wanted to frame it in the context if people aren't familiar with what open source is. So examples that are Linux. Apparently everyone's running Linux in this room, which is great. Underneath Android, there's Linux as well. LibreOffice, which I use to make this presentation, is also open source. Firefox, the web browser, is open source. So we're probably all very familiar with open source software. And open source refers to something that you can modify and share because the design is publicly accessible. So with software, we're talking about that you can inspect and modify and enhance the source code. So in the terms of, when we talk about open source, there's a couple different terms that people use. They might use free or libre or open source. And those do have different philosophical backgrounds. For the purposes of this talk, I'm going to conflate those terms, and I'm just going to refer to it as open source hardware, though some people use the terms free hardware, libre hardware, open hardware, but I'm just going to be using the term open source hardware for this talk. So open source hardware is hardware whose design is made publicly available so that anyone can study, modify, distribute, make, and sell the design or hardware based on the design. So this is a definition that we came up with about 10 years ago at an event called the Open Hardware Summit. People that were making hardware projects, we got together and tried to come up with a definition of what we wanted it to mean. So I mostly do electronics, though open hardware and open source hardware is more than just that. It can be mechanical design, basically any physical object where you have design files that you could share. But just to give you an example, in the context of electronics, what we're talking about is the schematic, the board layout, and then the bill of materials, the parts list. And we're not just talking about an output file like a PDF or a graphic file of the schematic or Gerbers for the board layout. We're talking about the editable source file from the CAD software, so something like Eagle or KiCad. And then one of the things that's good to do with the bill of materials is if you want to enable other people to be able to build your project, it's good to make sure that the components are available in low quantity. This isn't a strict requirement of the definition of open source hardware, but if you want people to be able to build your project, then it's important to make sure that they can build it in low quantities. So how many people have heard of Arduino? Okay, a good number of people in the room. So Arduino was a microcontroller board that was created at a small school in Italy like over 10 years ago. And it became super popular because it was good enough at the time to do a lot of different interactive electronics projects. And they shared the hardware design and the code on the internet. And it just kind of achieved critical mass. A lot of people took it and modified it for different projects, different use cases. At the beginning, I had a link there to the slides. Also, if you pull up the talk page, there's a link to the slides as well. I have a lot of links in these slides. One thing that's interesting is there was a documentary back when Arduino was starting about the team. Just wanted to check out to see what things were like when that was starting. So one of the most popular Arduino boards is the Uno, which you see a picture of there. So how do we know that the Uno is open source hardware? Well, if we go to the Arduino website, we can see that the design files from Eagle, which is the CAD software they use, is there. And we can download that zip file, and it has the schematic and the board layout. Now, when we're releasing our design files for a hardware project, we need to choose a license. And there's a lot of different options when it comes to licenses. One is the Creative Commons suite of licenses. So one common one you might see people use is CC BY, means attribution, and then share alike, SA. One thing to note is if you add the non-commercial attribute, then that makes it not open source. In the slides, there's a link to a good blog post that kind of explains why if you add non-commercial clause, it no longer conforms to the definition of open source. Other people use things like copyleft licenses or reciprocal licenses like GPL, also permissive licenses like Apache and BSD, MIT. And then there's licenses that were created specifically for hardware projects, one of which is the CERN Open Hardware License, which I wanted to talk more about specifically. So CERN, the physics laboratory here in Europe, they have a open hardware repository. So they're developing these electronics, and actually there was 2 great talks here at Congress from a couple of electronics engineers that work on the electronics there. So they're building electronics for their physics experiments, and they want to share that with other labs around the world. So they have an open hardware repository, and as part of that, they created the open hardware license. And kind of give some background on this, one of the people that runs the team there is Javier Serrano. He gave a cool interview that's linked in the slides where he talks about their motivation behind this and why they have the open hardware repository and created the license. Though this can get kind of confusing, there's not just licenses, there's also copyright and patents. At the Open Hardware Summit a few years ago, Ari Douglas gave a nice talk about this, so you can find that talk in the link there. In the slides. He goes over what might be good for your project depending on what purposes you're trying to achieve with your project, and kind of goes over a lot of the different options there. But what's the whole point of all this? So the reason you might want to make your project open source hardware is that you want to enable collaborative development. So we're talking about the idea here is that you're going to share your design files and you're hoping other people will help contribute to your project, contribute to the design of your hardware. So I would say that's like the main reason to release the design files for your project as open source hardware. If you're not interested in other people collaborating on your project, then it might not be the right thing for your project. So it's good to consider whether or not you want to have other people contribute to your project. So I mentioned, or it was mentioned at the beginning, I'm part of the Open Source Hardware Association. So we're a nonprofit based in the US. But though we do have board members around the world, we have Matthias, who's one of our board members in Vienna. I'm actually based in Berlin now as well. So one of the things we do is we host the definition of what open source hardware is. We also have things like best practices guide, a checklist that you can go through to see if you're releasing all the things you need to for an open source hardware project. But the main thing that we do is we help organize this event called the Open Hardware Summit. And that's going to be coming up in March of 2020 in New York City. So hope to see some of you there if you can make it. This will be our 10th one. So we started in 2010. This year, though, we decided to do something a little bit different. So we had Open Hardware Month. So the idea with this is we wanted to have people from around the world do locally organized meetups and talks and workshops. And that kicked off with one in some in Vienna and Colorado in the US. And it was really cool. We had 40 events in 14 different countries. And we'll be doing it again in 2020. So hopefully some of you can get involved with events wherever you're located. And if you're wondering what happens at the Open Hardware Summit, you can check out the talks from our last one, which was in 2018, to give you an idea of what happens there. And kind of some insight into the different sorts of projects people are doing. I do a lot of electronics, but there's a lot more than that. There's people that are doing science and art and design, all sorts of different things. One of the other things we do at the Open Source Hardware Association is we have a certification program. So this is a self-certification program. You go to certificate.oshwa.org and you fill out the name of your project, the license you're using, link to your design files, link to your documentation, and then you get this logo that you can use. And kind of one of the value of this, if you're making a project, is you can put that on your packaging, or I put it on like the silk screen on my board. So then people can really easily identify that it's open hardware, and then they can go to that website and they can type in the ID number and be able to pull up the page that links them to the documentation, the design files. And then for people that are looking for, like I want a certain type of device and I want to find one that's open source hardware, if you see this logo, you can go and look that up in the database and find out more about it. So if you're interested in know more about the Open Source Hardware Association, you can go to oshwa.org. You can join as a member of the association. We also have a mailing list and a forum. If you want to check us out on Twitter, the OH Summit is the Open Hardware Summit account. We have a lot of activity going on right now about that because it's coming up in March. And our executive director, Alicia Gibb, who's one of the people that started the summit, she wrote a book called Building Open Source Hardware, and it has essays from different people that have built open hardware projects. So it's a good thing to check out if you're wanting to see what different experiences people had with that. So the point of all, the main theme of this talk was about Linux on open source hardware, which is my two favorite things. So one of my favorite projects was developed by Bunny, who gave an awesome talk on the first day here at Congress, and Sean Cross-Sobs, who's giving a workshop right now on the FOMU. So this was a completely open source laptop where everything, including all the electronics, were open source. And at the time when this came out, like 4 or 5 years ago, it was a pretty decent system. I have one and I used it for many years. So this was a really cool idea of having a laptop that I can use every day that's open hardware. And it had some cool features like an FPGA and a software-defined radio. And then if you're wondering what's kind of coming up next, if you go to the CDC area here at Congress, you can see the Reform laptop. So Lucas from MNT is there. He has this as a completely open source hardware laptop, the electronics, the mechanical design, everything. So I recommend you go check that out. It's really cool. It's in the CDC area, which is the Critical Decentralized Cluster. So one of the other things I'm involved with is beagleboard.org. So we're a nonprofit organization that helps design open hardware computers. That is everything for people from makers to students to even professionals that are designing into their projects. And what we do is we work with different manufacturers, and we also work with the community to come up with designs that are useful. So this started off with the beagleboard back in 2008. So this was kind of the first low-cost ARM development board. And back at that time, a lot of people were needing ARM hardware to port their free software and open source software to ARM. And the board was pretty popular for that. We followed it up with a littler board called the BeagleBone, which fits into the Altoids tin, if you've seen those mint tins. If you've probably used the BeagleBone, you're probably most familiar with the BeagleBone Black, which was, I would say, still our most popular board. So kind of the theme here is because it's open source hardware, there's a whole bunch of different BeagleBones made by different manufacturers with different features and different price points. Like Seed Studio decided probably most people don't care about HDMI, so they took the HDMI off to save some cost. Arrow wanted to make one that worked with industrial temp, so it's a little bit more expensive, but it has industrial temp components on it. And then one of the things that's important with open source hardware is we want people to be able to take the design files and make derivatives. So we have the smaller one called the Pocket Beagle. And the cool thing about this is it's a pretty simple circuit board. It has something called the system in package that integrates a lot of the chips. So it makes the board layout really simple. So this is just a 4-layer circuit board, and it's available in Eagle and also in KiCad. And if you have some experience, like if you go over to the hardware hacking area, you can learn to do surface mount assembly, and with a little bit of experience, you could order the board, order the parts, and build your own. Or as Kumar did, he wanted to make a logic analyzer board, so he took the design of the Pocket Beagle and he added on the features he needed, like the inputs for the probes, and he also added in gigabit networking. So this is kind of cool to see people take the design of the Pocket Beagle and then modify it for their project, for their use case. And then here's an example of the logo. So the latest board we had was the BeagleBone AI. So we registered that back in the summer. So it's US because it was registered in the US. It's the country code, and then it's 169. So it's just like a sequential number. So it's easy for people to identify if they go to the GitHub. Okay, it's open source hardware certified, and they links off to the page on the database with information about it. So I wanted to mention Alimex. We're here in Europe, and in Bulgaria is one of the best open hardware companies, in my opinion. And they have a line of open source hardware Linux computers called the OLinux we know. The person behind AliMech, Svetlin, has a great blog post about open source hardware and why it matters to them. So a few years ago, they wanted to create a ARM 64-bit ARM board that was completely open source and designed in KiCad, which is free software, open source circuit design software. And Svetlin gave a nice talk at FOSDEM a few years ago about the process of them switching from their proprietary CAD software over to KiCad and designing this open source hardware board. So, and then if you've not heard of KiCad before, or KiCad, doesn't really matter what you say. Some people say KiCad, some people say KiCad. But it's open source software for designing circuit boards. It's cross-platform, it runs on Macs, Windows, and Linux. And one of the cool things about it now is there's developers at CERN that are working on it, and the project leader, Wayne, is now working on it full-time as his job. So it's cool to see a lot of the developers now being able to do it as their day job. So it's kind of getting critical mass in that way. And if you want to try it out, I recommend if you search on YouTube for Getting to Blinky, it's a nice tutorial about teaches you how to go through and make a little board that blinks an LED. So AliMech took that board that they designed in KiCad, the Linux we know, A64, and they wanted to make a laptop with it. So that's called the Terrace One. And the design files are on GitHub for it. So the idea there is to make a modular laptop that people can put different boards in and things like that. Another interesting open hardware project was the chip, which you might have heard of. It was billed as a $9 computer. They had a really successful Kickstarter back in 2015. Unfortunately, the company went out of business in 2018, 3 years later. But the cool thing about it was all open source hardware, the schematics, the PCB, the bill of materials. And if you see here, there's this really cool thing called the Pocket Chip, which was this nice like handheld little Linux computer. It was really cool. But the company went out of business, which was unfortunate. But this one person, Christopher, he goes by Grogard, he designed his own board that